Okay, gentlemen, we're going to look at this practice problem, which will be good practice for our quiz, which we have next class, quiz 2.2. It'll be one problem just like this, and then I'll ask you to kind of tell me everything about it, all these 10 subjects or 10 characteristics that are on, that's the same characteristics from your homework. For async, you'll have another 2 problems of this. So by the time you take your quiz on Tuesday or Wednesday, you'll have done 2 for async, 2 for homework. This video on the Canvas assignment details or on my YouTube page for Mr. Daniel Hasselbauer. You see there's going to be this video plus 2 other ones. One's from async 2.11, slide number 4, and then one is from the one I started in class with my guys. So if you subscribe, you watch all 3 of those videos, you do both problems for the async and both problems for the homework, you should be ready to go for your quiz on Tuesday or Wednesday. And if you subscribe to that YouTube channel, you'll get updates when I post new videos, or if I were to share myself being featured into St. Cott's upcoming song. That would be great. If you all subscribe, I make bank. If I make bank, St. Cousins become famous. Okay, I'm looking at my domain. My domain is based for rational functions. My denominator, I am eliminating only the values that will make my denominator 0. Everything else is good, I just can't divide by 0. So I look at this, first step is going to be factor the denominator. Factoring the denominator will help me see, when I break it down into prime factors, what numbers I can't use. So I took out a GCF of x, I'm left with x squared minus 9. I can still do more. We've done dots, difference of 2 squares, many times. And now these are 3 prime factors. X minus 3, x plus 3. 3 prime factors. I cannot use the number 0 for the first one. If I do, it makes the whole denominator product be 0. Can't divide by 0. If I plug in a 3 to the second factor, that factor will become 0. Times by everything becomes 0. Can't divide by 0. And then over here, I can't plug in a negative 3 because that'll make this factor 0 and then everything 0, which we don't want to divide by 0. So 3 numbers I'm skipping. My domain, I'll list it out. I'm going to have a union, 3 unions because I'm skipping 3 numbers. I'm going to go in number line order. So my negatives come first. I'm going to union it with my next closest number, which would be 0. And then my third number I'm skipping 3. And then I go down to infinity. So negative infinity till 3, this is skipping 3. Up till 0, this is skipping 0. Up till 3, this is skipping 3, and on forever. So I've skipped a negative 3, a 0, and a 3. Is my function continuous? Well, of course not. I have 3 numbers I'm skipping. 1, 2, 3. Once there's one number I skip, it's not continuous. It's only continuous if my domain is all real numbers, in negative infinity up until infinity. Once I skip a number, not continuous. I want to find out if there's a removable discontinuity, which I would write over here, or is there an infinite discontinuity, which means vertical asymptote. How do I check that? Well, if I factor my numerator, this will help me see if there's anything I can cancel out. So I took out an x. Again, I have an x as a GCF, and I can see that I'm definitely going to have stuff I can cancel out. I can cancel out my x and my x minus 3. I can cancel out 2 of my 3 factors on the bottom and both factors on top. So this would reduce to just a simple 1 over x plus 3. And this is my reduced form. Okay. Since I'm able to cancel out the factor x, that means the root that came from that 0 is a removable discontinuity. If I'm able to cancel it, it's called removable at 0. I also canceled out my x minus 3, okay, which means the root that comes from that, the 3, is also a removable discontinuity. at x equals 3. Okay, 3 came from this factor, x minus 3, because 3 would make that 0. I canceled it with the top. That's removable. Discontinuity at 3. X and x, that a 0 came from that. That's the root that comes from that factor. I canceled out that factor, so there's removable discontinuity at the root 0. The only one that's left is x plus 3, rather, which means the root that comes from that is the only one that doesn't go away. So there is an infinite discontinuity at x equals -3. And I should probably go like this, actually. So 2 removable at 0 and 3 from those 2 factors I canceled. The one left over, a -3, was where I have an infinite discontinuity, and that is exactly where I have a vertical asymptote. Vertical asymptotes occur at infinite discontinuities. It's always the same. Always the same. So these are the same as expected. Okay, horizontal asymptotes. We know that that's based on our degree of our numerator compared to the degree of my denominator. I'm writing this down so I talk slower. Denom, that's an N. Denominator. Well, let's see. On the original, x squared and x to the third. The bottom is larger. The denominator is larger. So that means we do have a horizontal asymptote at y, because it's horizontal, equals 0. Every time the degree, meaning the power, x to the third, of the denominator is larger than the degree of the numerator, x squared, there's always a horizontal asymptote at y equals 0. Okay? If the top were larger, if this were an x to the third and this were x squared, there would be none. Okay, for my y-intercept, that occurs whenever my x is equal to 0. So I take my function, I plug in 0, and let's see what happens. I plug in 0, plug in 0, plug in 0 to the bottom, and 0, and I get 0 minus 0 divided by 0 minus 0. That's 0 over 0, but I am not allowed to divide by 0. So what does this mean? I am undefined. Why? Why does that happen? Well, I was going to skip number 0 anyway. I wasn't allowed to use the number 0 anyway. The value x equals 0 is not in my domain. So it's no surprise that when I plugged it in, I got a problem. Well, we kind of knew that already. And I'm just going to highlight up here so that line's not in our way. Here's the 0 that is not in my domain. I also had a removable discontinuity at 0. So it's no surprise that 0 created the problem. So I don't have a y-intercept. So there is no y-intercept. No y-intercept. It's going to look like there should be one, but there's not going to be one there because I'm undefined and it's removable. Undefined, not in my domain. It's removable because I canceled it out. So what does that mean for my graph? There's going to be a hole in my graph where there should be the y-intercept. Okay, x-intercept is normally based on the numerator, right? But I'm actually able to cancel everything out of the numerator. So there is none here, because it's based on the numerator. We also could just kind of look at our graph, but based on the numerator, but I reduced it, but reduced to just a 1. So it ends up not happening. And we'll look at our graph and we'll kind of see the only part my graph would have kind of crossed well, there's a horizontal asymptote there, so I actually never cross it. So we'll see that. Okay, now after this, increase, decrease, max, min, range, all has to come from our picture. So right now, I haven't even looked at my graph. Now let's look at it. Okay, I should have it saved. I did a plus, it should be a minus. Here we go. I'm going to go like this, and I'm going to try and split screen. Okay, good. Increasing and decreasing. Well, I can kind of see that my function as x is going from negative 16 to negative 15 to negative 14. So as x is getting larger, my y value is getting lower. Negative 1, negative 0.1 rather. So that means I am decreasing so far from negative infinity. Okay? And I'm going, what do I expect to happen at the value negative 3? Well, I can see up here, negative 3 is where there's a vertical asymptote. I see that. At negative 3, so as at x equals negative 3, and if I do that, there's my negative 3, which is an asymptote, right? So I'm decreasing all the way up to that asymptote, right? And I can't decrease anymore. And then all of a sudden I reappear up here. I happen to skip over it over here on the red graph, and I'm still decreasing, still decreasing, still decreasing. So I skip the number 3. It's not in my domain, so I'm not allowed to decrease anywhere past that. And now I keep going to the right, I'm continually decreasing. 0.9, 0.8, 0.8. So I'm going all the way decreasing forever, and I never actually increase. Never. We can kind of see from our graph, I'm going down, and then I randomly appear up here for the vertical asymptote, and I'm going down again. Here's my y-intercept. 0 is not in our domain. Going, 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 bam. Right at 0, I'm undefined, as we expected. 0 is a removable discontinuity, where my graph is not defined, so I'm not allowed to use that number. The next number I was able to remove would be a 3, and we see right here, bam, bam. At 3, I'm undefined as well, because that was the other removable discontinuity. I crossed out an x minus 3, so 3 is undefined. Okay, so actually technically, I really should say that this goes from negative 3 to 0, and then 0 to 3, and then 3 to infinity, because technically I can't say I'm increasing, I can't say I'm decreasing everywhere and then include numbers I'm not allowed to use. So basically my entire function is decreasing, skipping negative 3 for my asymptote, skipping 0, not in my domain, skipping 3, not in my domain. But basically, I'm decreasing everywhere. I guess I'll write next to this, everywhere. Everywhere in my domain. Okay? Max and mins, we can kind of tell my function is decreasing forever. So there's never a point where I flip from increase to decrease or decrease to increase. I don't turn around ever. So there are no points. No points. No locals, no absolutes, none. What about my range? Well, we can kind of see that my range is a little hard because range is still difficult for us. But I use every number except I skip over 0. Right, and then I'm going this way. And I guess I skip over the values I should get when I plug in 3. And I skip the value I should get when I plug in 0. Those are really the only 2 numbers I skipped. A little difficult to find those numbers. We'd have to plug them in and then see what I would get. So for right now, I'll actually just say that this is negative infinity. I skipped the number 0 to infinity. I probably won't ask something too crazy like that. My function is it even or odd or neither? I am not symmetrical in quadrant 1 and 3 or 2 and 4. And then if I fold my graph down the middle, I clearly am not an even function. So I am a neither function. A neither function. Again, our range I wouldn't worry too much about. Technically, like I said, you're skipping this number, which looks like it's probably 1/3, I guess. Right, so it looks like you also skip 1/3 because your graph never gets to 1/3, and then it looks like you skip somewhere over here, which 0.164 looks like, and 0.164. But a little tricky there. I wouldn't go crazy doing that. It would be kind of a simpler one. But we really need the first bunch of points, domain, continuous, vertical, horizontal, y-intercept, to make sense. Those are the important ones. Okay, I would probably take the graph and screenshot it into this, which we wrote down, and then good luck on those last 2 problems for your async assignment.